Hi, I'm Jordan, and welcome to the first video in a series I'm calling What Software Development Can Learn from Other Industries. The idea is simple. Other fields such as medicine, aviation, logistics, they've all been solving complex operational problems for decades. And a lot of what they've been figuring out also can apply to software development. So we're going to do a deep dive into various frameworks and principles from other industries to see how they can make us better at what we do. Today we're going to start with manufacturing and specifically the theory of constraints. So let's dive right in. Now I want you to imagine a factory floor. You've got these 5 stations that are all trying to work together to build one product. Station 1 can process 100 units per hour, Station 2 can process 50, etc., etc. So my question to you is, how many units does this factory produce per hour? And 50, if that was your guess, you're correct. That's it. It doesn't matter what the other 4 stations can do. The system can only move as fast as its slowest point. This is the theory of constraints, popularized by Eli Goldratt in the book called The Goal, which I highly recommend. And the insight is almost frustratingly simple. Every system has exactly one constraint, and improving anything that is not that constraint is just the illusion of progress. You could double the speeds of station 1, 3, 4, and you'd spend a lot of time and money, but your output is still 50 units. The author in this book has a pretty great analogy. So you want to picture a troop of Boy Scouts hiking single file along a trail, and they all walk different speeds. Over time, what happens is that gaps form. The fast kids at the front pull ahead, the slow kid in the middle, in the book his name is Herbie, he falls behind, and the kids behind Herbie all bunch up behind him. By the end of the hike, the troop is stretched across a mile of trail. This is a great analogy for our work processes because this might sound familiar, but as certain tasks are faster than others, they might sprint ahead while others lag behind, and the whole release might get held up waiting for one thing. The solution proposed by Eli Goldratt is elegant. You want to put your Herbie at the front, your slowest walker. Now he's the one that's setting the pace, he's the one setting the rhythm, and everyone walks to his speed. There's no gaps, the troops move as a unit. And if you want the troops to go faster, you don't just yell at your slow walker, you figure out why he's slow. Maybe he's got an extra heavy backpack. Or maybe he's tired and he needs a break. Maybe he has bad shoes. You want to find that root cause and fix it. That's called constraint management. So each team will have stations, and it'll vary by team as we were just saying, but we each have them, and each station has its own throughput, and each one can be your team's own personal Herbie that is the bottleneck slowing everyone down. Maybe your team writes code faster than your QA team can review it. The work piles up, developers sit idle or start new work, which creates more pile up downstream. Or maybe requirements are coming in half-baked, so the devs burn cycles asking questions, waiting for answers, or even worst case scenario, they're building the wrong thing. This factory floor is your software development process, and it will be up to you to kind of look at your team's process and figure out what your stations are and what you can view. For the majority of software teams, our factory floor is a Kanban or Agile board in Jira or Azure DevOps. And we all have blocked tags or maybe a blocked column, but we all also have that experience to where you get to the retrospective and you're looking at why things were slow or didn't get done, and it's like, oh, I was blocked, and that doesn't do a whole lot of good. What you want to do is turn your blocked items from simply saying blocked to, hey, this was blocked for this reason. It takes 5 seconds, but it turns that pain point into an actual data point. Jira, Azure DevOps, they all have timestamps for when things enter columns, how long something was in QA for, how long it was in development for. These are all data points that we should be tracking to help us find our Herbies. help us find our bottlenecks in our processes. So now we have identified our constraint, we've identified our bottleneck. Let's figure out what we're supposed to do with that. Let's use QA as an example since every team has been there. Step 1 is to exploit the constraint. Maximize what the bottleneck can do. Don't waste a single moment of its capacity. For our example of QA, that would mean prioritizing their queue, making sure that most important things are being tested first. Reduce their interruptions, making sure that they have only the absolutely mandatory meetings and people aren't pinging them on Slack or Teams with quick questions. Making sure that you're automating what you can. If a human doesn't need to do it, a human shouldn't be doing it. Maybe you're taking development resources and having them instead work on helping automate your bottlenecks processes. Step 2 is to subordinate everything else to the constraint. And you might need a second because this one's kind of counterintuitive, but hear me out. You want to slow down the non-constraints. If QA can only test 3 user stories per sprint, the developers shouldn't be finishing 10. This just creates a pileup and all this context switching chaos because developers aren't going to sit idle. They're going to be picking up other items or sitting on their hands. And if they're switching on to other items, that's one is creating more of a pileup for QA in the first place, but then your developers, their attention, their context switching to a whole different story, or maybe even an entirely different project, and that's slowing down their progress as well. So we want to adjust the dev pace to match the QA capacity in our example. We want to limit the work in progress. Making sure that we're coordinating teams' efforts will help maintain a smooth workflow. Yes, this might feel like devs are quote-unquote underutilized, but utilization isn't the goal, throughput is. Our customers, or whoever that may be, stakeholders, they don't really care how much stuff we're getting, how fast our development is. What they care is, what are we getting that's actually being used? What's our throughput? If something's not done, it's not done. That's what people care about. That's what your stakeholders will care about. A factory where every station runs at 100%, but nothing ships is not a successful factory. And now we've reached step 3, which is to elevate the constraint. This is the step in which we're investing time and money to help remove some of those blockers. Let's stick with our QA example. That could be hiring additional QA engineers. That could be automating their processes, improving the CI/CD pipelines. This costs time and money, which is why we do it last, but it's essentially free. And here's the beautiful part. Once you elevate QA enough, it's no longer the constraint. Something else becomes the new bottleneck. You look at your data points that we've gotten and you repeat this entire process for that next constraint. And then the next one, and then the next one. And what do you know? We now have continuous improvement. And we are constantly speeding up our teams, speeding up our stations, and removing our Herbies one by one. From all of this, there's a number of changes. One is that your team's retrospectives, or when you look back on your work, they're now actionable. You're able to back things up with data. You are able to advocate with evidence. You're not spending time optimizing the wrong things. There's no sense in improving our security review process if that only takes 1 week while QA process still picking on them, but while our QA process takes a whole entire month. This allows you to kind of focus on speeding up the entire process by focusing on those bottlenecks. And then the big one that we talked about is context switching. If everyone's working on the same pace and everyone's working on the same goal for the same product to be made, we're not context switching, which then slows them down. We're focusing on just the one at a time. So that's pretty much it. There's a whole lot more I could get into, but I didn't want this video to be too long. And if this is something that's interesting, this is going to be a whole video series to where I'm going to be diving into different industries, such as logistics and aviation and medicine, figuring out how they approach certain things that software development can take from them. So thanks for watching, and let's get better every day. One last quick thing. I do want to make a mention that while we're talking about bottlenecks, it's very easy to have subject matter experts as bottlenecks. If you have one guy that's constantly being pinged or messaged and he's the guy that's putting out all the fires, that's very common and a very big bottleneck. Anyways, just want to throw that last one in there.